Arduino is a great tool for controlling electronic stuff like sensors and motors. But if you want to build logic into your Arduino program, then you need to understand how to use control structures in your code. In this lesson, we are going to go rapid fire over several super useful control structures, probably the most important ones. By the end of this lesson, you're going to have an understanding of how they work and how to use them. Let's go. Now, before we start, I'd really appreciate it if you take a moment to subscribe to the channel and like the video. It doesn't cost you but a click, but it really helps bringing you great content like this Arduino workshop. Now, this video is part of a series, and where we left off was talking about variables. So if you haven't already, I highly recommend after you watch this video, going back and watching the previous lessons. Okay, so far we've talked about how every Arduino program is laid out. Then we talked about, using variables. We're going over a little variable example. We sprinkled in a couple of these most important Arduino specific functions, namely pinMode and analogWrite. But now we're going to start talking about these control structures. What is a control structure? A control structure allows you to adjust the flow of your code. If we go to the Arduino reference page and we go to structure, when I'm talking about control structures, I'm talking about these right here. So we have an if statement, fors, else, whiles, switch cases. These are the control structures that are going to allow you to have your code do different things depending on different circumstances. So let's go back to that code and we'll see we have this if statement. So this is some control code. And notice it's followed by an opening and a closing parenthesis. And inside this is called our condition. So if statements have a condition. If the condition evaluates to true, then the code inside the curly braces gets run. If the condition evaluates to false, then all the code in here just gets skipped over. So you only do the stuff inside the curly braces of an if statement if this is true. Now you might be looking at this and being like, wait, what is going on here? Well, we've got two things going on. So this right here is actually an OR symbol. So this condition is saying, if the brightness variable is less than or equal to 0, or if the brightness variable is greater than or equal to 255, then do something. So, why don't we just evaluate? Well, let's pretend we're the Arduino and let's evaluate this. So what did we say? We said brightness was 5. So if brightness is 5 less than or equal to 0? Nope, it's not. Okay, well, is 5 greater than or equal to 255? Nope, it's not. So that means we're just going to skip over this line of code right here the first time through the loop, right? Okay, so we've controlled our code flow because we haven't used this based on a condition. So then we get to this next line of code and it says delay 30. Here's another one of those super important Arduino functions that you'll learn to love and hate. It's called delay, and what it does is it stops the program in its tracks. No other code will run for the amount of time you put in here, and this time is in milliseconds. So for 30 milliseconds, we're going to say stop. Don't do anything, Arduino board. And when we say stop, don't do anything, what we're saying is don't execute any more code. Because what we did up here on line 13, when we PWM'd pin 9 to a value of 0, that means the LED was off, right? There's no brightness there. And we're just going to hold that position. So delay is kind of like hold it. Okay, go. That's what's going on here. So after the delay, we get to this final curly brace. Here's the end of this loop function. And what do? We start back up at the top. So we're back at the top. We run into our friendly function analogWrite again using the PWM feature of the microcontroller. And what is brightness this time? Well, if you recall, last time through, we changed brightness to 5. So now brightness is 5. So that increases the on time for the duty cycle. And that means this LED is going to be on ever so slightly. So now the LED is going to turn on dimly. Now it's not going to turn on dimly because we've applied a lower average voltage to it. It's actually going to come on dimly because of the ways our eyes work. So the LED is going to be flickering on and off at a rapid pace. It's not going to be like somewhat on and somewhat off. It's going to be full on and full off. But the frequency of it coming on and off tricks our eyes into thinking that it's actually dimly lit. And that's how PWM works with LEDs. You're able to make a fading effect of the LED by adjusting the duty cycle of that PWM signal. All right, so we can see the LED dimly. Well, down here, what do? Well, now we're going to take brightness. That was 5, right? And we're setting it equal to brightness plus fade amount. Well, what is brightness? Well, you might be tempted to think, well, hey, yeah, we set brightness to 0 up here. Well, actually, brightness got updated before. So we're working with the latest and greatest brightness, which was 5, right? So 5 plus fade amount, which was set to 5. So that's 10. So now brightness is equal to 10. Now we come back down to our if statement, and we are checking the condition. But the condition really hasn't changed, right? Because 10 isn't less than or equal to 0, nor is it greater than or equal to 255. So again, we're just going to skip this code. Now we delay, we say it, hold it, everybody. We come back, and you can see we're just going through this over and over again. And what is happening? Well, what's happening is brightness, this value, because of line 16, it keeps increasing. It gets bigger and bigger and bigger. And so we see this LED fade on slowly. It's going to get brighter and then brighter and then brighter. So we're going to see it fade on from dark to brightness. Well, what happens when this value gets to 255? Well, when this value gets to 255, then this if statement, this condition is going to be true, because brightness will be equal to 255, which means the code in here is going to run. So our control structure is going to affect that flow when brightness gets to 255. And what does it do? Well, it flips the sign of fade amount. So it says fade amount, which was 5. It sets it equal to negative fade amount, which makes it -5. And then we delay. So that's interesting. -5. Okay, so we said brightness was 255, right? So we come up to this loop. Brightness is still 255, so that LED is going to be like fully bright, fully lit. We come down to brightness. Now brightness, that's 255 plus -5. So what's a positive number plus a negative number? Well, you basically do a subtraction. So now we're going to go down to 250. So now we'll be going from a high brightness to a low brightness because fade amount is negative, so we'll be subtracting from brightness until we get down to 0. And then this if control statement is going to flip it again, and then we'll add, and it's just going to go back and forth forever and ever and ever. And that's just a basic idea of how this flow works. So let's look at another example of a control structure. Let's look at a switch case statement. Here's an example of another control flow mechanism function called switch case. And what we're doing here is we have a sensor hooked up to one of our analog pins. And if you recall, the analog pins are connected to the analog to digital converter on the microcontroller. So pins A0 through A5, 6 pins on Arduino Uno using that ADC. And what that ADC is able to do is take an analog voltage and convert it into a number between 0 and 1023. So what this program is doing is it's going to read the value of the sensor, and then based on what that input is, it's going to print out something different to the serial monitor. Now, we haven't talked about the serial monitor, but we are in a second because it's super important when you're using the Arduino IDE. But let's start at the very top here. Look, we've got 2 variables. They're both integers. One is called sensor min and one is called sensor max. Sensor min was assigned to the value 0, and sensor max, you see we've initialized it to the value 600. But what's this const in front? Well, this is constant. And what this is saying is, hey, these variables aren't going to change throughout the program. This is called a qualifier. And you'll see this pretty often. You only use this for variables that don't change. Okay, here we are in the setup. And we see a super important function called serial.begin. So there is a code library called the serial library, and begin is a function that's part of that library. And so to use the begin function, first we write the name of the library, which is serial. We have a little dot, and then we follow it with the name of the function, begin. And we're passing into it this value 9600, which is the baud rate. All seems kind of odd, just a lot of details here I'm kind of skimming over. But essentially what this does is it allows us to communicate on the serial port between our Arduino board and our computer. So there's a tool built into the Arduino IDE called a serial monitor. I'll open it up right now. And what it does is it allows us to display text from the Arduino board to our computer. Okay, so serial begin initializes that serial communication. Super important function. Don't worry about the 9600 now. Just go with it. Again, it's just the rate of communication. Okay, so we go through setup, then we jump into the loop. What's loop do? It goes over and over and over again. And what are we doing here inside the loop? Well, it looks like we are declaring a variable and initializing it to a value. So we're making an integer, we're calling it sensor reading, and we set it equal to what? What is this? Well, this is a function, right? We see the name, and then we see these parentheses here. AnalogRead is another one of those super duper important Arduino functions. AnalogRead uses those analog pins, so analog pins 0 through 6, and it allows us to use the ADC to read a voltage. But all it needs to know is, hey, what pin number do I need to read that voltage at? And so we're saying pin A0. So if you want to refer to those analog pins, you can use A0, A1, A2, A3, A4, A5. So you just put an A in front of the number. Now, we could have made a variable out of this. We could have made a byte called sensor pin and set it equal to A0. We could have made it a constant since it's not going to change. And then we could have taken sensor pin and put it right here, just like that. So now what's going to happen on this line of code is that analogRead is going to look at this sensor pin, pin A0. It's going to read the voltage, and whatever the ADC returns, it's going to be a number between 0 and 1023. It is going to store it into sensor reading. So now sensor reading is going to be equal to whatever that value was. Line 14, a little bit confusing. It's using a map function. Now this is a Arduino specific function. It's not super duper important. It's still useful. What map does is it takes one range and it converts it into another range. Basically what's going to happen is you pass in the existing range and then you want to transform it into a new range. I'm not going to go into it now, but basically what it's going to do is it's going to squish down the number. So as that sensor value changes, we're either going to get a 0, a 1, a 2, or a 3. And that's when we finally get to this switch case here. So the switch, notice that there's a parenthesis following it, and inside there is a value. And this value is going to determine which case we actually take on. So here we've got case 0. So when the value is 0, we're going to execute this code. When the value is 1, we're going to execute this code. When the value is 2, this code. And when the value is 3, this code. Notice the break statement after the case that says, hey, when you get to the break statement, it's going to jump us out of that switch case. So you're only going to do one of these cases. So in this loop, we're going to read the value at the sensor. We're going to map it to a small condensed range. And then we're going to do something based on the value. And in this case, we're using the serial library again, but we're using the print line function from the serial library. And this is what is actually going to print something out to the serial monitor window. So after we get down to the end of the switch case, we have a short delay, just 1 millisecond, and then we jump back up to the top of the loop. And what do? Well, we read the sensor again. Well, why would we read the sensor? We just read it, didn't we? Well, we're going to read the sensor because the idea is that our Arduino is constantly checking the sensor. It's always on the lookout. Hey, did the sensor change? Did it change again? Is something different? So every time through this loop, which is running rapidly, the Arduino's on the lookout for a change. And when it sees a change, this switch case can react differently. So I'll go ahead and upload this. And I'm going to open up that serial monitor window. And you'll see it's low. And the sensor I have attached, I actually just have a potentiometer attached. And a potentiometer is like a dial. Think of like on a amplifier or on an old school radio, you know, as you turn that dial to change the station. So I'm just going to slowly change this. And you can see as I change that, the value is changing. Sensor reading is changing because the value at sensor pin is changing. And as I adjust it lower, it's doing that as well. So you can see, again, how this control structure is helping us adjust what happens in the sketch itself. All right, we're going to look at one final sketch, and that's going to cover some of those other super important Arduino functions. So let's go to File, Examples, Button. So now this is a sketch that is going to check for a button press. So this circuit looks something like this. We're going to have an LED attached through a 220 ohm resistor to pin 9, the other side going to ground. But then we're adding in a button. One side of the button is connected to pin 2. The other side of the button is connected to ground. So you can forget about the potentiometer, just look at the LED and the button here. So what we want this code to do is look at that button, and we want to change how the LED is reacting based on what the button's doing. So in this case, when we press the button, the LED is going to turn off. And when we're not pressing the button, the LED is going to be turned on. All right, so what do we have at the top? We've got some variables. Should be familiar with these by now. We've got button pin. We set that equal to 2. And LED pin, we set that equal to 9. Again, that's where we've connected our hardware, right? The button at pin 2 and the LED at pin 9. These are set as integers. They could be bytes, but it's okay to have them integers. And then they're qualified as constants. They're not going to change, so that's why they're made as constants. But then we have a variable called an integer called button state, and it's set equal to 0. Now the button can either be on or off, so we could have set this equal to a Boolean, but setting it equal to an integer is fine too. Then we get to our setup function, and we're using the pinMode again. So we can use the pinMode function to set those pins as outputs, like we're doing with the LED, we're setting it as an output, or we can set a pin as an input. So we could just do input like this, but we can also set it to an input pull-up. Now, I won't exactly get into what pull-up resistors are and all that stuff right now, but basically what it's saying is, hey, we're going to set this pin to a high state, and if you want it to change, you need to pull it to a low state. But for all intents and purposes, we're saying, hey, we want that button pin, that pin 2, to be an input. And if we wanted, we could just do input. But in this case, we're just going to go with input pull-up. All right, so in setup, which only runs once, we're going to use pinMode to set one pin as an output and one pin as an input. And then inside the loop, what do? Let's see. First line of code we come into, we've got our variable button state. It's set equal to 0 now, and we're setting it equal to this function, digital read button pin. So here's another super important Arduino function, digital read. We know it's a function because it's got those parentheses, right? It takes a value in here, and it's a reserved function name. It changes to the color orange. And what digital read's going to do is it is going to read the voltage at that button pin. And it's going to check whether the voltage is high or whether the voltage is low. Now, in our case, when we are not pressing this button, since we made this an input pull-up, pin 2 will read high. But when we are pressing that button, what we're doing is we're introducing ground voltage. And so pin 2 is actually going to read ground voltage when we press the button. So that would be a low voltage state. So when we don't press the button, this is going to be high. And when we do press the button, it's going to be low. High is represented by a 1 and low is represented by a 0. So if we don't press the button, then digital read is going to return a value. What's that value going to be? If we're not pressing the button, it's going to be a 1. So then button state would be assigned the value 1. And then we get to some control flow. We've got our friendly if statement. And we look at this condition in this control flow. And it's saying, hey, button state equal high. Hey, what is this? Isn't that an assignment operator? Well, notice that it's an equal. This is actually checking for equality. So it wants to know, hey, is button state equal to high? Well, we said it was, right? Because digital read, it was reading button pin. If we're not pressing the button, it would be a 1, it would be high, right? So this is true. And if that's true, we would run the code inside the if statement. And in this case, we come to another super important Arduino function, digital write. So we had digital read a second ago. That's for reading digital inputs, either on or off inputs. And digital write is for creating an output on those digital pins, either a high voltage or a low voltage. So digital write, it's going to take two values. First, it needs to know what pin to apply the voltage at, and then either a high voltage or a low voltage. So in this case, the voltage is going to be high. We want that LED to be on if we are not pressing the button. So now we see another part of this control flow. It's called an else. So notice that the else comes right after the end of this if statement, and it's got its own curly braces. And what this else is doing is saying, hey, if the if statement is false, so if this is not true, go ahead and do this other thing. So if this, else do this, right? So if we're not pressing the button, then we're going to write the voltage to LED pin low. So what this control flow is going to allow us to do is check the current button state. And then whether or not it's pressed, it's going to do one thing or another thing. Now we could make this an else if. And if we add the if there, we add another if, we could add another condition in here. Like maybe we had two buttons and we said, if the other button is high, then do this. Won't do that now, but just want to let you know that that's something that you can do. All right, I know that was a lot. We talked about how every Arduino program is laid out with setup and loop. We talked about variables, how they're buckets for storing information. how you can declare them and initialize them, and the different data types there are. We talked about a couple control structures, namely the if statement, the if else, and also the switch case statement. Now there's a lot of other control structures that are really useful. For example, a for loop and a while loop. We won't get into those now. And then throughout this whole conversation, we've been talking about the most important Arduino specific functions: the pinMode function, digital write, digital read, analog write, analog read, and then the serial library functions, serial begin, and serial print, and serial print line, and then finally the delay function. Now, I know that's a lot to take in, but really that just laid most of it out right there for you. It's really these basics that allow you to do tons of stuff. So all the stuff we talked about here is core critical stuff that you need to kind of get into your brain and practice, play around with. Go into those example sketches, see if you can see any of this stuff, see if you can follow some of the control flow. Now, we've only scratched the surface though. It's going to get really exciting because we're going to start talking about Arduino libraries. And what Arduino libraries are going to let you do is start using all different types of hardware by simply using other people's code. So we'll look at some examples of how libraries work with Arduino and how you can leverage them to get your prototypes running super fast. If you have any questions about this lesson, you can leave your questions in the comments. I will do my very best to answer them. I would love if you could like this video if you enjoyed it and subscribe to the YouTube channel. I look forward to talking to you about Arduino libraries next.